We introduced the actual circuit device, that is error core transformer, by using the concept of mutual inductance in lecture 81. In lecture 2, based on the simplification of the error core transformer, we presented the unity coupled transformer. In this lecture, we will further simplify the circuit and put forward a basic element, that is the ideal transformer. The ideal transformer is a 4-terminal element which have 2 voltage and 2 currents. These are 2 linear algebraic equations between them. Let's review the unity coupled transformer first. The unity coupled transformer is a lossless error core transformer with a unity coupling factor. Its equations of the port voltage and current are like this. That is to say, the port voltage meets a simple algebraic relationship with real coefficient, but the port current has an algebraic relationship with complex coefficient. On the basis of the unity coupled transformer, we can think further. If the permeability of the magnetic core is very large, or the number of turns is very large, so that as L1 tends to be infinity, then this item tends to be 0. So the port voltage and the current of the transformer are only simple algebraic relation with real coefficient, and the relation between them only depends on the turns ratio n. This assumption is possible. In the practical industrial applications, the permeability of the magnetic core is very high, and the number of turns is also numerous, so this item is almost close to 0. Under this assumption, we have the model of the ideal transformer. In the model of the ideal transformer, there is a simple real algebraic relation between U1 and U2. Between I1 and I2, there is also a simple real algebraic relation. So the transformer can change the voltage and the current. Ideal transformer is a basic element in our principles of electric circuit course. It is a 2-port network. The port voltage and the port current meets 2 algebraic equations with real coefficient. Before discussing the properties of the ideal transformer, we need to emphasize that besides permeability tends to be infinity, it needs another condition so as to eliminate this item. Turns ratio of N1 and N2 is constant. That is, the ratio of L1 and L2 is constant. If we only enlarge L1 and keep L2 as constant, it cannot meet the first constraint of the voltage. Now we discuss the properties of the ideal transformer. First of all, the ideal transformer can realize the impedance matching. We connected an impedance Z to the primary side of the ideal transformer. Then what is the equivalent impedance seen from the primary side? This circuit is not difficult to analyze. We only need to list equations. For the ideal transformer, we have U2 and I2 are non-associated reference directions for the secondary impedance, so coupled the 3 equations, we can derive that. Seen from the primary side, ZEQ equals U1 over I1 equals N squared Z. Do you find? The ideal transformer makes the impedance Z in the secondary side seems to be N squared Z in the primary side. So it can realize the impedance converting. You can refer the example in lecture 81. The error core transformer can also realize the impedance converting. Next, we discuss the power consumption of the ideal transformer. Here we discuss the instantaneous power absorbed by the transformer. Seen from port 1, the voltage and the current are associated reference directions. So does port 2. So the instantaneous power absorbed by the transformer is. We substitute the relationship between the voltage and the current of the transformer we have. What does it mean? For an ideal transformer, the instantaneous power absorbed is 0. That is to say, the transformer is an element without energy storage and dissipation. It only has a function for transmitting real-time signal or energy. It is not the same as a unity coupled transformer, which has an impedance of j omega L1, and it needs to absorb reactive power. While the instantaneous power absorbed by the ideal transformer is 0, so we call it ideal.